So my name's Matt. I work at a company called Teague. We're a design consultancy. We're sort of all over, but we're mostly based up in the Pacific Northwest, and we're celebrating 100 years this year. So we do all kinds of very exciting work. We do a lot of work in aviation and mobility, automotive, and then lately a lot of work in space travel and defense as well. And you know, we're kind of a fun group of people. We're a lot of prototypers, designers, engineers, and we sort of live this philosophy of thinking through making. So we always build whatever we're kind of coming up with, and we just had a guy retire after 46 years. I think he has the record in the company. It's something we're very proud of. He's a cool guy. I early on in my time, I was doing a talk about the company, and I found some black and white photos, and I see this guy in there smoking a cigarette, painting, and I was like, that's Fred. So I call him and I say, hey, Fred, like, is this you in the photo? He goes, oh yeah, there's the best times. It's at the end of a project, instead of, you know, rendering something in CAD and it takes like 4 hours or something. He's like, we would paint for like 3 months. And he said, all we would do is smoke cigarettes. The biggest enemy was ash on your painting. They'd smoke cigarettes and they would barbecue together, and anyway, different times. I'm going to talk to you about stuff that we're doing now. We do render quickly now because we have to, and we're doing a lot of work on the forefront of AI, autonomy, and robotics, and I'll kind of munge all them together and talk about sort of how I see human-machine interaction evolving. So I want to talk about control today. So how humans have controlled machines and how machines have started to control themselves, and then what happens when those two things kind of overlap and intermingle. And then along the way I'll share some stories from work that we've done and just some examples of some of the stuff that we've done and kind of how we build trust into experiences in sort of everything going on with AI and autonomous systems right now. And then at the end I kind of want to move into talking about what happens to interfaces and how we interface with machines in the age of AI and what that'll look like. So it's worth noting, I design interfaces and products for kind of complicated systems normally. So enterprise stuff, complicated things with the military. So I'll frame everything from like kind of a human perspective, but if you have comment, just jump in or we can do questions at the end. So right now we're crossing a threshold. People are probably feeling it, like we're in the middle of it. So machines are no longer just tools. They're no longer just automated systems. They're kind of becoming teammates a little bit more, right? With humans collaborating increasingly with very intelligent systems. And the real question today isn't like kind of how far that autonomy is going to go or how autonomous these systems should become. It's more, you know, how do we share in that autonomy and how do we collaborate? Because the future isn't, you know, only human control anymore. I think that Pandora's box is open, and it also isn't like kind of giving up to machine control. Although I'm sure I'll get some like questions at the end that might make me go a little bit more negative. I'm trying to be positive about everything that's changing. So I think the future is about collaboration. So kind of quick background, right, on control, because this will kind of help as basis for the talk. So we used to have direct control. That's what we've had, and we still have in many areas of our lives, and that's what we had for most of human history. So you swung something, you pulled a lever, something happened when you did that, right? You chipped a rock or you cut wood. So we had hand axes, and then we had water wheels, and then we had like early mechanical machines. But the relationship was it was very direct, right? It was immediate, it was predictable, but it had limits, right? And that's why we went through the evolutions we've gone through. The human did all the thinking, right? And the machine just amplified effect in those scenarios. And as systems got more complex, that model breaks under kind of like cognitive load. The human can't be everywhere, they can't do all the thinking. So we automated. At first we automated mechanically, and then now we've been automating more digitally. We started encoding rules into the machines that we built, so writing scripts, programming behaviors, that kind of thing. And the machine can now act on its own for times, or for long times in some cases, and humans define the instructions and the system just kind of executed on them, right? So the more advanced version of that, but still in the same spectrum of kind of programmed control. Machines could act very independently at this point, right, as we get into this world, automating large chunks of what humans would otherwise do. And that often increased precision, but it also introduces It allows for scale, but it introduces like a fragility into the systems that we now rely on, right? Programmed autonomy scales very beautifully until the world changes. And what do we know about the world? It always changes. Things happen, and different things need to then happen as a result of those. So the system, these systems can't kind of truly understand context, just follows instructions. So even the more advanced versions we have today like this, we're still scripting behaviors and like following rules in the machines that we build. This is an example of some of our stuff, and I'm going to kind of talk about it in the negative, which is not how I normally do it. But a few years ago, we designed a visual programming interface for AWS, mostly for all of their IoT kind of services that they provide. So if you've never heard of that, or a WYSIWYG like interface, WYSIWYG, what you see is what you get. It lets you kind of like manipulate things visually, and the goal here was like no code automation for factories, small buildings, different things you wanted to automate with sensors and digital systems. So, sorry, the video's done. But instead of writing code, so people connect like blocks together and do it all visually, right? It was very successful, but that's not why I mention it. What we started to realize is that, man, like you run into an issue with these things that I think hits on kind of like one of the key problems with programmed control and why we need to kind of keep going as humans. We noticed there was a point of complexity. This is another example here of scripting for video games, for Unreal Engine, that kind of thing. We noticed there was a point of complexity where programs were likely to become pretty unwieldy and actually like brittle in execution. So it's very evident in like no code interfaces, because you can see how complex they get. Visual programming kind of shows you, hey, there's a limit to how much we can plan for here. But it's a reality even for like actual coded programmed interfaces as well. As you try to accommodate kind of like larger and larger scope, more and more context, you just kind of like get to a point where it's unmanageable. You can't actually kind of continue to maintain that in light of all the technical debt that you kind of build up. So now we're at this new threshold that's kind of related to all those. With automated systems now combining with AI, we see an emergence of kind of a new type of control. And it's been around for a while in some sectors, but it's becoming more common in everyday life. But with that come kind of new problems, new sort of opportunities as well. So today, most systems sort of exist in this world, and we're starting to move into this. So most systems keep humans in the loop, right? So that means that the system can't actually, like the machine can't connect or cannot act without human input from you. The human's part of the control cycle, and we're now moving to this different kind of world for us and how we interact with machines, where we're on the loop, with the system can act on its own, and the human kind of supervises and intervenes when necessary, and that creates some new kind of challenges. And we call that like shared control. That's kind of how we refer to it internally. So a good example of that is the Mars Perseverance rover. This should play at some point, but it's not important. It holds all these like planetary records for like going the furthest on Mars versus like every other vehicle we've ever put up there. And roughly like 85% of its navigation is handled completely autonomously, right? So the human sets the objective, but then the rover actually, and this is what's different than program control, it figures out how it wants to achieve the objective by recombining its capabilities and sort of doing stuff. So now the action on the machine side is largely like unpredictable, right? So you're kind of watching a sequence of events happen to complete the objective, but you didn't define them. So you're only checking in if there's an issue, and there's really no direct control at this point in the kind of traditional sense, which is a big shift. And what we see when that kind of happens is when we work on these systems, we see the same problem kind of emerge over and over again. I think this will be true for anyone that's making things in sort of the new digital era. And we call that the trust gap. So that's my funny mind the gap picture that relates to that. But that's the only relation. But really, it's when machines kind of like act unpredictably, then humans can hesitate. And then if humans hesitate, often they intervene too late, and then you have systems that fail, right? Which is not good if you're designing a product on behalf of someone. So we find that the friction that kind of shows up in that scenario is not, it's not technical, it's actually more relational than it is anything else. So in that, we kind of live by these three principles that build to trust in all of the digital products that we make today. So we have legibility, so that's like, can I understand what the system's doing, right? Which seems simple, but now that you've got this in your head, you'll see how many products kind of fail at this. The spinning bar with no indication of what's happening is probably my favorite bad example. Predictability, so it's can I anticipate what it's going to do next, becomes very important when actions are going to be taken on your behalf and you're not holding the axe anymore. And then recoverability, so if something goes wrong, how and where do I take over, right? And in our work, and where we sometimes pick up work because it's gone badly for the client, autonomy without trust, can feel very risky, even if the user and the people participating in it know it's like statistically better, safer, anything else. We see trust break down when you're not doing these things, and that can really impact how folks sort of accept new technologies that are introduced to them. So a lot of our work over the past few years has been designing for how humans engage with increasingly autonomous systems. So this is some work we do a couple of years going with this client now, where they're called Overland AI, really cool partnership. They've developed and are now refining an autonomous drive system for off-road capability, right? So no humans in the car, uncrewed vehicles, and particularly for defense applications like supply running and things like that. So Teague was enlisted to design the operator interface for these vehicles. So that's like the command and control interface that like a commander who has a bunch of these would use to tell them what to do, plan missions and all that kind of stuff. And a lot of our trust principles show up in this kind of work. What's going to show up here in Overland AI parlance, and it's true of a lot of autonomous drive companies, this is called like a cost map. So what this is showing, anything that's like hot pink or black or anything like that, it's essentially like, I can't go there. They call it their crushability index. So they're essentially saying like, hey, I can't crush the trees, and you can see as it drives through this crop of trees, they're all highlighted, but I can crush all this brush around me, so I'm gonna go after the brush. And so it's just how costly is it for me to run over this item. Now, that visualization is basically just like the robot's brain, visualized. Engineers love it because they can debug with it and see what's happening and that kind of thing. But operators technically don't need that at all. There is nothing they can get, really, functionality-wise from that. And if you were, not thinking through trust in your product design, you might choose not to include it. But what we found is every customer we go talk to, when we show them different options, they all want that cost map to feature pretty prominently in the interface, even though it can't really help them. They can't do anything to intervene, but that's all because it builds trust, right? So I know what it's seeing, I know what it won't do, where it's likely to go, and I know that it's working. So that's kind of why they want to lean into that. And the trust problem, it extends into tons of other categories too. Another example of some work we do, we work in the, I'd say, more consumer space, doing a lot of autonomous vehicle work with companies like Mobileye, Waymo, and we've done a lot for OEMs as they've explored what they're going to do as well, so Ford and companies like that. One of the things we run into there when you put just sort of a human where it's not their job to be there is that they are very sensitive to trust, right? So when you put someone in there first time, a lot of the time they're like, you'll take my car from my cold dead hands kind of thing, and they're very afraid of the technology or very resistant to it. But once you sit them in there and you start to show kind of some of the ideas that are more trust-based, you can kind of get further with them. And the trickiest thing here is these systems, all autonomous systems, AI, everything, they perceive things that humans simply can't perceive at a different speed, more information, and they have extrasensory, almost superpowers, right? So they can see in every direction. Like I said, they can also interact with data that's coming from other vehicles and infrastructure. So it's just a complete kind of shift tech-wise. An example of that is a vehicle might slow down because it sees a pedestrian through fog in a way that you can't see, right? And that's a weird thing if you're in a vehicle and it's not telling you what's going on. It may reroute based on a traffic sensor 3 blocks up the road that you're not even aware of yet, and you're like, wait, why the heck is it going to a different route, and it's rerouting, right? So from the systems perspective, those decisions are all obvious, those behaviors are all obvious. But from the human perspective, they can feel very mysterious, So, which means the interface has a new job. It has to over-explain why the machine is behaving the way it is. And we're seeing the same happen with AI products and kind of everywhere in our business. The smarter the system becomes, the more important it becomes to make its behavior very legible and trustworthy. And we did have a bunch of UC students working on that stuff, so that was cool. They essentially built the prototype that you saw kind of running in there. So shared control has this trust gap, and the greater the level of control or autonomous sort of capability that the AI, the robot, the autonomous vehicle, whatever it is, the greater level of control it has, the greater that trust gap can feel if you fall down on any of those principles. And we see it a lot in like mission critical work, but we also see it, like I said, in consumer work. And it's really important for, as product makers, that you bridge that gap. Anyone putting an experience out there, otherwise you see sort of a rejection in that tech, and it can take a lot longer to sort of establish paradigms and like kind of how that stuff can live in the world. So in shared control, just to kind of like go through it, humans contribute like judgment, ethics, intent. That is way different than like they're on the knobs and levers, right? So that's like a evolution of kind of how things are going. And then machines contribute like perception, so pattern recognition, the ability to scale, the ability to like highly contextualize things. Humans are good at that too, but machines can do it sort of in a more infinite way than we can. And then the interface in the middle becomes the negotiation layer, right? And I think this is kind of what I wanted to now sort of bridge into talking about, is like where I think things will go next. So at this point, the next big opportunity isn't like just AI and all the capability itself. It's the interface layer. Again, the interface layer has been an opportunity before. It's kind of coming back around. And that's where we kind of decide, right, as people that design these things, how humans and machine are going to actually collaborate. Right now, you know, a lot of AI interfaces, I'm sure you're all experimenting, doing different things. They're pretty primitive, right? You have chat windows. You may have a visualization of kind of what the robot's seeing, like I showed you earlier with the autonomous car. And those are useful starting points, but they won't be enough to kind of like continue to increase human capability in light of the technology that's coming. And that's the positive spin, right? I don't want to see a world where we give up like that level of control. I want it to be collaborative, right? And so if we want systems that people can truly partner with, systems they trust, we're gonna have to rethink the interface layer. Because we'll hit a limit. I'll go through another example here with, we'll hit a limit with like the way we craft interfaces and products today. It's very handcrafted, right? Just as we did with programmed control, when you saw all those branches in that big spaghetti diagram, we hit a limit. We had to come up with other ways of doing things, that time on the machine side. So an old client from, I don't know, 6, 7 years ago, we worked with them on all of this defensive-based like targeting system, I'd say. It had physical products that people wore and punched things into. There was sensors and cameras and radar, and there was command and control. They came back to us and they said, hey, remember that great work you did for us where you designed that system that tracked 3 targets a minute, because that was the requirement back then. Well, post drones and everything else, they came back and said, hey, how do you think we could track 2,000 targets a minute? And we all sat there going, oh, holy shit. Then they started to break down kind of what they had been up to in the interim, and what we quickly realized is the machines could handle it now, right? There was, AI had become a part of their software package. Sensors had advanced in a way that could provide this capability, but something else hadn't. The interface layer was breaking almost immediately under the weight of kind of the new needs, the new AI-enabled needs. And then we realized something that was kind of uncomfortable for us. The machine layer had evolved faster than our capability to design interface for it, right? And then the second we sort of realized that on this project, we started realizing it on like much of our work, like on the cutting edge stuff. We're like, oh, we need to come up with a new way of thinking about this stuff. So we'd hit a limit, right? Machines couldn't handle the complexity before, so we invented automation. And now we've hit a new limit, so machines can handle the complexity, but the humans can't, right? Because they really need that interface layer to do the job. So that means like next evolution won't happen at the machine layer, it'll happen at that interface layer. So kind of where I see things going, and this is not fully worked out, it's more sharing, it's something I've been writing about, and like I said, UC gave me the floor, so I was like, I'm gonna try this out on the crowd at South by. So, you know, I see an era of shared control combining with what we've been calling emergent interface. There's other people talking about this, we're not the only ones for sure. So it's essentially a conceptual framework for flexible systems, and I'll kind of unpack that. And this is where we're like focused with some of our more cutting edge clients now, which has been fun. So historically, when we design in like the way we do, I'm giving it a very negative term here. I've had a great career doing this kind of design, and it will continue for a long time. I'm seeing Jeremy over there. It's a real thing. But historically, we've designed for every outcome, right, in the way we work. So that's every flow, every screen state, every light that comes on and off, every possible response. And we carefully bake that into our product, and then we release our product, and then when there's things that need to change, we'll do patch or an update or something like that. And that worked until the systems themselves have become kind of like too flexible to predict in like the traditional way. And just like the example I showed earlier, our current approach to interface design becomes brittle in light of kind of new machine intelligence and when the systems underneath it become kind of dynamic. So the next era is going to demand a different approach, which is what we've been talking about as emergent design. So instead of designing fixed interfaces, we'll design systems that adapt real time on the fly. So systems that respond to very fluid goals, changing context, and users who aren't all the same, which surprise, they were never all the same. We just had limited ability to answer for all of their needs, right? So in the past, we delivered interfaces. Now we'll deliver frameworks, right? So these frameworks will evolve, they'll adapt, and support outcomes that I think crucially we didn't explicitly anticipate, which is quite a change for anyone that's in the world of creating product. That feels like losing our power in a way. But I'm like, hey, it might not have been ours to have in the first place. So instead of hard coding stuff, we'll design building blocks and controls that only appear when they're needed, or interfaces that are assembled dynamically, or even like recombined to create new controls that we weren't predicting. So that'll all be real time and based on user preference. So that'll obviously challenge the heck out of like anyone that's building products today. And like almost any type of product. I think you can be pretty broad in the way you look at this. So, we were traditionally architects of that fixed experience, carefully shaping all of the screens, all the interactions, but in emergent systems, we won't control everything anymore, which is weird, at least not in a traditional sense. Instead, we'll kind of like guide the system and how it kind of shows up, but we won't like literally handcraft it. So we'll become cultivators of all the building blocks, all of the kind of documentation that guides how they can recombine so that we make sure we are achieving the goals of the company we're working for or whatever we're doing. So we'll create the rules and the guardrails and all the building blocks. And increasingly, I think our role will be, and I don't mean this to sound sad, I think it's going to be an interesting evolution, just like when Photoshop was a thing, or when Fred went from painting things to, and I'm sure on some level he said, oh, I got a lot of time back, and then they went, yeah, but do it quicker now, but we'll leave that out. Increasingly, I think we'll design things that are machine readable, so the machines are better capable of recombining them, and I think that's true of the design pieces themselves, the components, the buttons, the knobs, the dials, the lights, the sounds, but also all of the documentation, right? So our role shifts from controlling all the details, and I know I'm repeating myself here, to kind of like defending intent and quality and kind of how it shows up. But really, I think what's important is that means that like new skills become really important to us. And they've always been there, but now they are like the thing. And that's our judgment, our ability to curate, our taste, our understanding of human goals, our ethics, our empathy. Those are the things that we then kind of become important in the role of like future product makers. And then, because I have to talk about the opportunity, otherwise it's all for naught. And this is where I think the exciting stuff happens. We won't just be building more products. I'm sure businesses will look at it that way, like faster, cheaper. That's not the part that excites me. We'll be able to build products that do more and do more on behalf of people. And I think we can start to get into systems that really scale human capability instead of just replacing it, and kind of move into, I won't call it like next stage of evolution, but like into the future, right? So there's exciting stuff that can come from that. Because historically, and this is that thing I mentioned earlier, we make a lot of decisions as product owners and people that build things about like what was an edge case, and we're not going to focus on it, what's not worth spending money on, or which users we designed for and which ones we didn't, right? And even though we all kind of said, hey, this is the right thing by the most users and by the business, in reality, we always had limited time. There's limits to how much complexity we can bake in, like I talked about earlier, and there's limits to like the money that companies want to spend to do things. And that meant we left a large portion, even if we thought we'd gotten 80%, 60% of that 80% had a different idea of how that should work, right? So it's just a very lossy process, and I think emergent interface as a concept can kind of push us into a space where we can meet people where they actually are, right? And that's pretty fascinating, instead of where we predicted they'd be, which is what we're very good at. And like I said, I've made a real career of doing that. We won't have to do that in the same way anymore. I find that kind of enlightening. And that can unlock like a new era of accessibility, I think, as well, right? You can interfaces that adapt to people's like real true needs, their context and preferences in real time, maybe their context if that's a problem, but a layout that shifts to, say, like accommodate a physical limitation. I don't have this excuse, but whenever I'm typing on my freaking keyboard, I hit the period button instead of spacebar all the time. And my wife gets these texts, no spaces, and it's highlighted like it's a freaking URL, right? And that's not useful for her. But you know, we'll be able to do things to accommodate different physical limitations for people. We'll be able to kind of have controls that move based on how someone like actually holds their phone or where they are in relation to an interface. You'll be able to do things where like, you know, you get in the car with your kids, and if the first thing you're always doing is like drilling in through an app to playlists to the playlist they want to play, that'll be able to like emergently just bubble to the top, not in a pre-programmed way, so that can be hyper unique to you, right? And there'll be a big button that just says play this thing, and you don't have to swear where it's coming from, how it connects. And then interfaces, they could even simplify themselves to like help someone that's feeling like overwhelmed and change the amount of information there, or someone that's tired, or someone that has like a cognitive issue, right? So, you know, I think that's an exciting kind of future, and I think one that's afforded from this kind of theoretical concept I'm throwing around here. So emergent design will give us like a new toolkit. Instead of building interfaces for predefined jobs, which like I already said, we were often kind of wrong about a lot of the time anyway, even if we convinced ourselves we weren't. We design systems that learn and adapt and evolve alongside people, which is more human, I think. So if you're a designer of products, and you know, I know this is a very mixed audience, but hopefully people are getting something out of this. Remember these kind of things, right? If you're designing a product, you have to focus on legibility, predictability, and recoverability in the age of autonomy and AI. That's important to keep the human empowered. And then the interface layer is once again, just like it was with the advent of touch smartphones and everything else, it's the place where I think the next big shift will happen once more. So that's important to bring humans fully into the age of AI. To do that, we've got to move beyond the way we build things in a fixed, rigid way right now. And that's moving them towards systems that collaborate with us, right? To keep us empowered, like I said. And really, like, I got into design, I think, because I'm a sci-fi geek, and I always go back to Star Trek for different examples, but it really is like the computer make me a cup of tea and make it hot kind of future that we're now kind of on the edge of. And I think that's, you know, I hope that excites people. We're just getting started. So if you're a maker of anything, I think there's a lot of opportunity ahead of us. And I wanted to provide that versus some of the fear that kind of exists around AI and stuff today. That's it. Thank you. Appreciate it.